Welcome to our video tutorial of question 12 of our daily review. Question 12 is talking about graphing the solutions to systems of equations. Now, there's a couple of important vocabulary terms that we're going to define. Then we'll take a look at how we actually graph those solutions and what those solutions look like once we've done some graphing. First, we want to define the term systems of equations, and systems of equations are simply any two or more equations that are being compared with each other. Now, in this particular question, we are most often and most likely going to be working with linear equations, but remember that this is the comparison of any two equations with each other, so it is possible to see some things that are not linear equations. When we describe the solution to systems of equations, we are talking about the point on our graph or the time in our equation when both the x and the y values are the same. Since question 12 is asking us to do this on a graph, it's important to know what this looks like on a graph, and we would notice that on a graph, this is going to be the point or the place where our equations or the lines would cross. Let's go ahead and take a look at what this might look like on a graph. Here I've graphed two simple equations, y equals x plus 7 and y equals negative x plus 21. We know that the solution to the equation is the point on our graph when our x and y values of the two equations are the same. So that should be this point here, and it's 7, 4. In this case, we know that this is true because our lines graph there, but we can also verify that it's true by doing some real simple math. If I replace 7 in my equation, or my x value in the equation, so I'm going to replace x with 7 in my equation, well, I would notice that y equals 7 plus 7, and that means y equals 14. Notice the y value was 14. If I do the same thing in my second equation, I'm going to replace the x with the x value that was given to me, in this case 7. So y equaled negative 7 plus 21. Well, negative 7 plus 21 equals 14. We know that in both of these equations, when we have that x value, both of these equations will also have the same y value, meaning that this is the solution to our system of equations. Really quickly, I want to just talk about if you are given a table or a graph, you would use any of the skills that we've talked about in class about graphing a table, an equation, or a graph to put all those things together on the graph itself. If you need help with that, you can go back and refer to the video tutorial for question 9, which is talking about those tables or equations that are given to you. Finally, I want to take a look at a couple of different types of equations. So here is an example of a linear equation in blue, and we actually have an exponential equation in green. So this would be an example of two equations that are not necessarily linear equations. Notice something different here, that this particular set of equations or systems of equations would have two solutions because there are 2 points on this graph where our x and y values would be the same, or we would notice there's 2 points where these graphs cross each other. If I have two linear equations, and it doesn't matter what those linear equations are, if I have a positive and a negative slope like we saw in the first example, here I have a positive slope and a slope of 0. We could have two positive slopes. They are always going to have one solution to that system of equations. In this case, our solution is right here. It's where they cross right there. And there's only one exception to that when we're working with two linear equations. And that is if our slopes are the same, because that would create parallel lines. And this would tell us that there is actually no solution because there's going to be no point on this graph where our lines would cross, or no point where the x and the y values would be the same thing. Hopefully that gives you an understanding of how to work with graphing the solutions to our systems of equations.